Hey there. In this lesson, we're going to take a look at scientific notation and how to change numbers from standard notation to scientific notation and vice versa. But before we get there, we have our vocab word here, which many of you will probably guess is scientific notation. It's just our way of expressing numbers that are really big or really small as a product of a number that is at least 1 but less than 10 and a power of 10. Now, what does that all mean mathematically? Well, scientific notation I look at is it's right here. So A is going to be a number that's between 1 and 10. It can be 1, but it cannot be 10. And B is going to be an integer. So that's what I have right here. Our A value, that's that number that's greater than 1, less than 10. And here, that's the B value, which is our integer. And then the other piece of vocab that we had that I talked about just a little bit earlier was standard notation. That's just the normal way of writing our numbers like we're used to seeing them. Now, let's take a look at a little bit of example of 10 to a certain power. So in these examples here that I have, you're pretty familiar that 10 to the fourth means 10 times 10 times 10 times 10, which actually equals 1 and then 1, 2, 3, 4 zeros, so 10,000. If it was 10 to the third, it's 10 times 10 times 10, and that's going to equal 1 and then the 3 zeros, so 1,000. If it's 10 squared, it's 10 times 10, we end up with 100. 10 to the first, well, that's 10 times nothing else, and that just equals 10. Now the question becomes, what is 10 to the 0? Can I write that out like I did in these 4 examples here? Well, the answer is not really. So how do we figure that out? What I'm hoping that you're looking at and recognizing here is, as I went from 10,000 to 1,000, or 10 to the fourth to 10 to the third, I divided by 10. And then to go from 1,000 to 100, we divided by 10. And to go from 100 to 10, we divided by 10. So what are we going to do when we go from 10 to the first down to 10 to the 0? Well, we're going to divide by 10. And if we divide by 10, 10 divided by 10 is, oops, it's not the color I wanted. Let's try that again. 10 divided by 10 is, struggling, 10 divided by 10 is 1. Now we can continue that pattern because we're still going 1 less with our exponent. Right now we're at 10 to the 0. If we want to go 10 to the negative first, well, we'll continue to divide by 10. Well, what's 10, or what's 1 divided by 10? Well, the answer is 1 divided by 10, or 1/10. Now, as a decimal, we could write that as 0.1 or 0.1, either way, the fraction or the decimal. And if we continue this and we divide by 10 again, well, now we end up with 1 over 100, which is 0.01 or 1/100th. And we continue that process. If we divide by 10 again, well, now we're going to have 1 over 1,000, which is 1,000th as a decimal. And finally, we have 1 over 10,000, which is 1/10,000th as a decimal. Now, the reason I did that is that's going to help us when we get into writing scientific notation, which we're right here. So I have a couple of examples here, if you look down at the bottom, of 2 numbers that are already in scientific notation. What I want us to do is I want us to write those in standard notation. So I have a couple little steps here to get us there, some things to recognize. So it says in this first part, if the B is positive, then the number is big. We have a large number. And to get our number that's in scientific notation to look like a large number, we're going to move the decimal to the right, because then we're going to get that large number. But if that B value is negative, well, then we have a small number. And then we're going to have to move the decimal, many of you are already guessing this, to the left. So we get that 0 point something, 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 something. We get a small number. All right? So let's take a look at this example. I have the 9.62. So I'm going to write this down, 9.62. Now, notice the b value is positive. Therefore, we have to move this decimal to the right because we want this number to be big. So if we go 1, 2, 3, 4, and 5, our decimal place is now going to be right here. Well, what do we put in those spots where there's no number? Well, there we just fill it in with zeros, and now we have our new number written in standard notation, and that number is 962,000. So if we put our comma in here, we have the number 962,000. Taking our number that was in scientific notation and we put it into standard notation. Now, on the other side, we come over here, and now we notice that our b value is negative. Therefore, we have a small number. So this time, we have to move our decimal the other way. So we now have, we start with 2.85. And since we have a negative exponent, we have a small number. We need to make it look small. 1, 2, 3, 4, 5, and 6. Our new decimal place is going to be right here. And just like the previous problem, all these kind of blank spots, we're going to put zeros in there. And our new number is right there. So I'm going to rewrite it as 0.000000285. We took our scientific notation and put it into standard notation. Now in these examples, they kind of look like scientific notation, but they're not really in scientific notation because if we look at this number right here, what would be the a value, remember in scientific notation that has to be between 1 and 10. Clearly 73.2 is not between 1 and 10, therefore it's not in scientific notation, but we can treat it the same way. We have a number times 10 to the third power if we want it in standard notation. We're just going to take that number and we're going to move the decimal on it. So 73.2. Our b value here is positive, therefore that tells us that we have a big number. We need to make it look big, 2 and 3 decimal places, new decimal places right there. Fill in our zeros, and we now have 73200, which is 73,200. If I come over here to my example number 4, I now have the number 602, so I'm going to write that down, 602. But my b value, notice, is negative, therefore small number. Need to make it a small number. So remember, our decimal place is right here right now to start. And if we move to the left, 1, 2, 3, 4, 5, and 6, our new decimal place is there. Put our zeros here, and we end up with the number 0.000602. Oops. Let's write that the right way. 602. And we have put it into standard notation. My next one down here, I'm going to look at this one and notice that right away my b value is 0. So then when I think about 10 to the 0 power, if I go back to that, think back to that slide where I had all that 10 to the 4, 10 to the 3rd, so on, and I eventually had 10 to the 0, this part right here, remember, is just equal to 1. Therefore, if I take 5.98, multiply it by 1, I just get 5.98. So this one, when I started right here, my number was in scientific notation. If I want in standard notation, it's right there. This one, again, notice our b value is 0. Therefore, 10 to the 0 is just 1. And anything times 1 is itself. Therefore, this one will turn out to be 0.0021. And we have found our number written in standard notation. Now let's go the other way. Now I'm going to give you a number in standard notation, and we have to write it in scientific notation. So here's what we want to look at when we do this. We want to look at the number, and I want to think, is it a big number or is it a small number? And my definition of big number is all the numbers are to the left of the decimal. So we have this first example, 931,500,000. That's a big number. But my second one, number 8 here, is 0.00443. We have that small decimal. So 7 is a large number, and when we have that large or big number, then we think back to scientific notation and go, well, our exponent is going to have to be positive on the 10. But if we have this small one, like we do in number 8, then the exponent on the 10 in scientific notation is going to have to be negative. So I'm going to go to this 931,500,000. Right here, the decimal place is right here. We need to first find the a value, remember? And that a value has to be between 1 and 10. So I'm going to move my decimal until I get to a number that's between 1 and 10. I'm still not there. Right there, I'd be at 93.15. But if I go to here, now I'm at 9.315. I might have a number between 1 and 10. So my a value in this one is going to be 9.315. We don't put all the zeros on there. We're going to multiply times 10 raised to some power. Well, what power is that? This is where I'm going to go back and I just have to count this. So I moved it 1, 2, 3. These are kind of hard to see. 4, 5, 6, 7, and 8 places. So the exponent on my 10 is going to be an 8. So 9.315 times 10 to the 8th power is my number written in standard notation. Now my example 8 here, I'm going to do the same thing. But this time, I notice I have a small number. Therefore, the exponent on the 10 is going to have to be negative. I'm going to start where my decimal's at. I'm going to move it over until I get to a number that's between 1 and 10. Right there. If I bring it to right here, I'm at 4.43. That's between 1 and 10. Therefore, my a value now is going to be 4.43, and then standard notation or scientific notation times 10, and now to what power? Well, this is where I'm going to count how many places I moved. I moved it 1, 2, 3. But remember, since it's a small number, we have it to the negative 3rd power. And then I have completed my number that was in standard notation is now in scientific notation. My number 9 here, same concept, nothing's changing. Again, I notice that I have this small decimal. Therefore, I think in my head and I go, exponent's going to be negative on the 10. So I count 1, 2, 3, 4, 5. To get right here, I stop because at 4.955, that's between 1 and 10. I just figured out that my a value is going to be 4.955. And then we're going to multiply that times 10 raised to some power. Well, what power is that? Again, we come back here and go, I moved it 1, 2, 3, 4, and 5. So it's to the negative 5th power. There's my number written in standard notation. And then my last example here, I have 277,000. We have to figure out where the decimal is going to go. So first, start with where the decimal is at. I'm going to move it over 1, 2, 3, 4, and 5 to right here, because now I have the number 2.77, which is in between 1 and 10, a value, times 10 raised to, well, what power? It's 1, 2, 3, 4, and 5. Remember, we have a large number, therefore our exponent is going to be positive, and we have 2.77 times 10 to the 5th as our number written in scientific notation. So we've seen how to convert from scientific to standard and from standard to scientific notation, and that will now conclude my lesson on scientific notation.